Hello everybody, welcome to the class of Programming and Data Structures at the Indian Institute of Technology, Kharagpur, Autumn 2020. In this video lecture, we will discuss more on iterations and loops. If you have seen already my video lectures on iterations and loops, part 1 and part 2, then you must be familiar with the C syntax for handling iterations and loops. Those three syntax like while loop, for loop or do while loop are the basic for iteration and loop handling in C programming language. Today we will elaborate more on these iterations and loops. Let us start with an example program. So in this program, again I am not including stdio.h, that is has include stdio.h, but you must have to include that one since I have a printf statement. Okay. Now this program is with two integer variables fact and I, and it will compute the factorial of a number. Since I have seen this program previously, so I am directly going to that program, and you know that initialization of fact equals to 1 and I equals to 1 is required, where I is the loop variable. So my condition is that while I less than 10, then it will keep on looping, and inside the loop it will compute fact equals to fact multiplied with I. Okay. Now inside that one again there is an if condition. In that if condition it computes that during the computation, if the value of the fact goes beyond 100, then I will break. Okay. So this problem actually computes factorial of 10 at most, with a condition that the moment factorial will go beyond 100, then I will stop and I will exit from the program. Okay, and for exiting the program there is a break statement, and you will see that since this is the only computation, so this break statement will lead to the coming out of the loop, and there is a return 0, and that way I will exit from the program. Now in this while loop, basically you see that I less than 10, you are familiar with this while construct, and for this while loop the matching brace is here, and inside this while loop there is the statement fact equals to fact multiplied with I. After doing this multiplication, I will test whether fact is greater than 100 or not. For the first instance, since I initialized fact with 1 and I also with 1, so it will be evaluated as 1 multiplied with 1, that is 1, so it is false. So it will come out of this if condition, then it will increment I. After that it will go back to this while loop, and then it will compute this fact, then it will be 1 multiplied with 2 because I is incremented now, and after that multiplication it will be 2, that way it will keep on going. Now the moment it will encounter fact greater than 100 after the evaluation of this fact, then this condition will be true, and then it will print the factorial of how many numbers I is within 100, or factorial of I, this I is a variable here, is above 100. After printing that one, it will break, and you see although the break is inside if, but on the last tutorial what I mentioned that break will not work in if, it will work with the do while, for loop and the switch case. Since here there is a while, so it will work for this while. So the break indicates that it will break from this while loop, not from this if. And if I draw the matching brace for this if and while, then I see that the loop opening and closing brace for if is here, and opening and closing brace for while is here, the blue color the diagram. Now if I say break, then it will not come out from this if. If it is, then actually after coming out of here, then it will increment I, then it will go back to while as per the construct of the while loop, and that way you may think that then there is no need of break, because anyway after this printf statement, if there is no break statement, then also it will go to the next statement, that is plus I. Okay, rather it will break from the loop, and which loop? That is the while loop. So after executing this break statement, it will come out from this while loop, that is the control will go from here to here, and next the statement it will be executing is return 0. That way it will complete the execution of the program. Okay, here is another example of checking whether a number is prime or not. Now you know the logic. So if I have one number, by that if I divide the given number, and if I get the remainder as 0, means the number is divisible by any number up to that number but not including that number, then it is prime. That way the simplest implementation can be that you start from 2 and keep on incrementing the number, and at the same time you keep on dividing the given number, which is being tested for whether the number is prime or not. Then if there is one instance where I will find that division gives me remainder as 0, then I declare that it is not a prime number. Now in a simple loop, so if that is a definite loop kind of thing, then the loop will iterate from 2 up to n minus 1, where n is an input. I am testing whether n is prime or not. Okay, that way if I implement, then basically n and I equals to 2 is my integer variable. N I am reading from the terminal or from the user to check that whether n is a prime number or not. Then inside this while loop, as long as I less than n, so which means I will start from 2, then it will reach up to less than n, which means up to n minus 1. I am dividing this. So since it is a percent, so after this division I will get the remainder part. If the remainder is 0, which means that n is divisible by I, then I declare that okay, n is not prime. Now in a standard way I can keep on dividing that one as long as possible, means up to n minus 1, and if there is only one occurrence, at least one occurrence of the situation, or at least one occurrence of one I, by which if I divide n, then I will get 0 as a remainder, or if there is a division, then I will declare that it is a composite number. But you know, if I get one number which is divisible by say 2 or 3, then there is no need to proceed further. Say example is that, for example, if I give you say 1, 2, 3, 4, that is one number, and I see that I can divide 1, 2, 3, 4 by 2 itself. After dividing that one, if I find in my first chance or first occurrence, since I equals to I, that since I equals to 2, that 1, 2, 3, 4 is divided by 2, and after the division remainder is 0. If I know that one, then there is no need to go for further division from 3 to 1 to 3, 3, 1 less than 1, 2, 3, 4. There is no need to do that one, and in that situation the example of break is most suitable. What I am doing now, I am keep on incrementing I, that increment is taking place here, but before that I am testing whether I is less than n. If yes, then I am dividing n by I and checking whether the remainder is 0 or not, which means if n is divisible by I or not. If yes, then I declare it is not a prime and break out of this loop. So break out of this loop means break out of this while loop. When I will break out of this while loop, now you see the situation. When I will break out of this while loop, then definitely since I am breaking out of here, So this condition is true. If this condition is true, which means I is less than n. If I is less than n, then breaking out of here indicates that this number is not a prime. But if this condition is not true up to n minus 1, which means there is no number by which if I divide n, then I will get a 0 as a remainder. Say for example, if I take 31, then from 2 to 30 if I divide, then I will not get any I by which if I divide n, then I will get 0, then it will not be evaluated and tested as true. If it is not tested as true, this statement will not be printed, but that is not important. Main important statement is this break. If it is not true, then this break statement will not be executed. If it will not be executed, then this loop will keep on moving until this condition holds, that is I less than n. And since I am incrementing just by 1, so after the occurrence of in I as n minus 1, the next occurrence will be I equals to n. So when I equals to n, then this condition will be evaluated as false, because it is no more less than n, rather it is equals to n. So I am coming out of here. The moment I will break from this loop, because this particular condition is false, that indicates that I equals to n, and that also implies that this condition was not true. And if it is not true, which means there was no I by which I can divide n, and I get a remainder of 0, which means the number is a prime. That's why after coming out of this loop, so I am writing if I equals to n, then printf the number is prime. Okay. Again, to summarize, is that there are two exit way from this particular loop. One is normal exit because this loop condition is false. Another is the exit because of the execution of this break statement. If I am exiting from this while loop because I am executing the break statement, then this condition is true. If this condition is true, then outside the loop I is not equals to n. If it is not equals to n, which means that it is not a prime number, and for that I already printed. Whereas if this condition is not evaluated as true, then I will come out naturally out of this loop, because keep on incrementing the I will reach at a point at n where the value of I equals to n, and since value of I equals to n, this condition will be false, so I will come out. So I am testing here, if I equals to n, then printf that particular I or the number is a prime. But there are several other algorithms or implementation also for checking that whether or testing whether a number is a prime or not. So this is perhaps a better way to do that one. What I am doing now, I am declaring integer n to read the number which will be tested. Again I is initialized with 2, sorry. So starting with 2, then flag is one integer variable. I am setting that as 0 initially. Okay, why it is set as 0, then you will understand. Now double is another variable I am declaring, and the name of the variable is limit. So basically I am declaring one variable limit with the data type double. Now I am scanning or reading the n from the user and storing it in. Then I am taking the square root, and I know that if I go up to the square root, so that is enough. I need not have to go beyond that one. So from that point of view, I am computing this one. Now while I am computing this one, then what I am doing here, that I am setting a flag equals to 1. So last time what I did, that I tested that if this condition is false, which means that I executed this loop fully and it was never tested as true. That's why I declare that as a prime. In this case, another version, what I am doing, I am incorporating one flag variable which is integer. Initially it is set as 0, assuming that the number is a prime number, but if there is a division and the remainder is 0, then I am setting that flag as 1 and I am breaking. So after the break, I will see that if flag equals to 0, then it's a prime. If flag equals to 1, then it is a composite. Okay, that way what I can do, instead of printing here also, I can print completely outside at this position, that if flag equals to 0, then it's a prime, else it's not a prime. Or what I can do, that I can write if flag equals to 1, then it is not a prime, else it is a prime. Okay. Next, after discussing regarding the break statement, which actually allows me to break out of a loop, now I will incorporate another statement, that is the continue statement. It will be just opposite to the break. Break will break out of the loop and continue will not allow to execute rest of the part of the loop, rather it will go at the beginning of the loop. Okay. Anyway, so once the execution is over, rest of the part will not be executed if it is break or if it is continue. That way there is a similarity also between continue and break statement. So continue statement skips the remaining statements in the body of a while, for or do while structure. It proceeds with the next iteration of the loop. While and do while loop continuation test is evaluated immediately after the continue statement is executed. For structure, increment expression is executed, then the loop continuation test is evaluated. So for actually what will happen, expression 3 will be evaluated and then expression 2 will be evaluated. So more elaboration is like this. If say while expression statement is here, or say do statement while expression is here, then after execution of the continue statement, the control will go to the while directly. So rest of the part of these statements will not be executed. So here in do while, if you remember that block of statements are here. Now if I encounter that continue statement, then it will go to the beginning of the loop, but rest of the part will not be executed. And for the for structure, so if you remember that expression 1 will be evaluated only once, then expression 2, then statement, then expression 3, then expression 2, that like that way. That's why when I will encounter one continue statement here, then I will jump to expression 3. I will not go through the next statements of that for loop. I will skip that. I will jump to expression 3. I will evaluate expression 3. I will go back to expression 2. Then I will start executing the block of statements. Okay. So here is an example with break and continue, both in one simple program. Again, it's integer main, then int fact equals to 1, I equals to 1. Now while 1. Now you remember in the last video lecture we discussed that this is one way of having an infinite loop, because this one is always tested as true. So it is an infinite loop. Inside that one, what I am doing, fact equals to fact multiplied with I. So I am computing the factorial and I am incrementing the I. Now once the I is incremented, then I am testing whether I is less than equals to 10 or not. If I is less than equals to 10, then I am writing continue. If I write continue, then what will happen, that it is not done yet, go to loop for next iteration. So from here directly it will go here, okay, and the program will keep on executing here in this loop. So from continue it will go to while and then fact, then I plus plus, then this condition will be tested, then continue, it will go back if it is true. But the moment I will find that after the increment operation I is equals to 10, then this condition will be evaluated as false. So this continue statement will not be executed, it will come out, and when it will come out, it will execute this break statement, and because of that one it will come out of this while loop. Okay. So what I can compute here, I can compute up to factorial 10. Okay, not up to, I should say that I can compute factorial 10. So until I finish the factorial 10 calculation, so this will, the continue statement will not allow me to execute the break statement And although you can see that there is continue and break, but this continue is along with this or inside this if statement, but break is outside this if statement. So as long as this if condition will hold true, then this continue statement will be evaluated, the control will go to while, and then it will keep on executing. Okay, but the moment this condition is false, it will come out of here, break will be executed, and it will come out of this while loop. Okay, so here is the diagram which says that from continue the flow will go back to this while, and as long as this condition will hold true, then it will go back. Now you remember that since there is a single statement, so opening and closing brace is optional, but it doesn't mean that continue and break both are under if. Only one single statement is under if, that is continue. That's why as long as this I less than equals to 10 holds true, then this continue statement will be executed. After the execution of this continue statement, the control will go back to this beginning of the while loop. Now if there is a break statement, which means that when this condition will be evaluated or tested as false, then it will not be executing, this continue will not be executing, then break will be executing, and because of the execution of this break, it will come out of this while loop, which is actually the infinite loop in nature. Okay, so you remember these two things, this arrow from continue, it will go back to the beginning of the loop, and from the break it will come out of the loop. But in both the cases, so after this continue statement, whatever is there, it will not execute that one, and also after this break statement, whatever is there, it will not be executing that one. Okay, so in that way there is a similarity, but the dissimilarity is that continue goes back to the beginning of the loop and break goes out of the loop. Now while you are implementing this one, I will actually show you some pitfalls for this loop implementation. So what is that? And that is also the reason why I insisted that even if there is a single statement, it's better to give braces, opening and closing braces. Now if you do not give that one and mistakenly if you give this semicolon, you note these two semicolon after this while statement at for statement. Okay, so because of these two statement, then what will happen, this will be considered as one statement and this will be considered as one statement by C. So only this part will be evaluated. So which means I equals to 0, then it will be tested, then I will be implemented, then it will be tested. That way it will keep on going as long as this condition will hold true. After that it will come out. It doesn't mean that sum equals to sum plus I is part of for loop. Actually there is no statement, it's void. In this case it will be sum less than equals to num, since inside this one there is no way or no scope of changing the sum. If it is true, it will be true forever. If it is false, then it will be false. So always avoid this kind of situation and keep in your mind that it is always a good idea that you use opening and closing braces. Some other situations are given here. You must be careful about these situations. Next we are moving to a concept where loop is there, but loop will be nested in nature, which means inside one loop another loop will be there, and that's not very much difficult. Let us demonstrate with a printing example, very simple printing example. Here you can see that there are 5 star marks and there are 5 star in each row and there are 3 rows. Okay, now how to print this in the terminal? Clearly you can see that it is in a matrix format where there are 3 rows and 5 columns. So you can consider that first I have to repeat for 3 times in order to print 3 rows, and inside each row I have to repeat for 5 times in order to print 5 stars. And you are absolutely right about that one. For that, what will be the program? So program is very simple. Number of rows, since I mentioned that it is kind of a matrix construction, so number of rows is 3 and number of column is 5. Here I am initializing that one, and I am also confirming and declaring that this is constant, so it will not be changed. After few steps, so all the details of the program is not given, only the important part is given here. So after few steps, so I am initializing row as 1, and while row less than equals to rows, the small row is a variable which actually controls the row count, and capital rows is an integer constant which determines that how many rows will be printed finally. Okay, then print a row of 5 star, and then you have to keep on incrementing the row. Inside that there are a number of programs, and what is the program that is written on your right hand side, and that maps here. So inside this one I will initialize column with col equals to 1, similar to row equals to 1. Now I am looking for the column, then while column less than equals to cols, this cols is the integer constant 5. Okay, then printf star, and if you wish to give space, give that one. If you do not wish to give space, or space is not required, then do not give that one. Then call plus plus, means the column will be incremented and it will keep on looping. How long it will keep on looping? So calls is 5, so 5 times it will be printed. After printing that 5 times, one row printing will be done, then it will come out. Now if you remember, in each row there are 5 star marks. So after printing 5 star marks with a space as per this program, okay, then I will come out, then I have to go to the next line indicating the next row. So I am printing /n. /n is for the new line, and then I am incrementing the row, then I will loop inside this while loop, and after incrementing the row again I will go inside this while loop, and I will print 5 more stars, and that way I will keep on looping. Okay, so I will say that this one is my outer loop and this one is my inner loop. So inner loop will be running for the number of times the loop will run, that is calls, multiplied with the number of times this outer loop will run. So inner loop will run more compared to the outer loop. That is evident, and that you can see from this program also. Now 2D figure with for loop, how you can do that one. Before proceeding further, I will suggest that you pause it here and then you try it by yourself, and then you come back and cross check whether this implementation is similar to the solution or the example given here, or it is different. If it is different, then also it's not a problem, there may be different implementation. Okay, but if finally the result is same, like 5 stars separated by a space in one row, and if there are 3 such rows, then it's fine. So in the for implementation, it is a nested for, constant in rows, constant in calls, 5, 3, those are similar to the while loop. Now what I am doing, so if you consider the same nature of the while loop and the for loop, what was initialized before the occurrence of the while loop, that is row equals to 1, is now inside the for loop. Then row less than equals to rows, the condition testing which was there will be there. Now the last statement which was executing at the while loop was plus plus row is now as expression 3 in this for loop. This is the outer loop, the blue color for loop, red color for loop is the inner loop. Here the column will also vary like that way. Now printf star space. Okay, again you see that although there is only single statement, but I put that one inside the brace, and this will give me the confidence that okay, this part is for the inner for loop. And after the execution of this inner for loop is over, then I will come out and then I will print a /n to move to the next row. Once I will reach to the next row, then again I will go for the printing, and once the printing of the required number of rows are over, then I will come out of the outer loop. Okay, so these two examples are simple. The previous one was implemented using while, now it is implemented with for. Now if I ask you to print this one, What is the specialty about this one? In the first row only 1 star, second row 2 stars, third row 3 stars. So that way the number of rows is indicated by number of stars. How you can do that one? Again, I am suggesting you to give a pause to this video and try it by yourself. So here is the example, the constant int rows 5, okay, because 5 rows I wish to print. Now the modification what I have done, you see, is in the inner loop. So definitely the row column declaration as an integer will be there for the previous case as well as in this case. The outer loop is same because same number of rows I have to print, and also the printf/n is required for the same number of times that it was in the last time. The only difference is that last time there was a constant number of stars which is required to be printed in each row. In this case this is variable, but although it is variable, but there is a pattern, and that pattern says that the number of stars are equal to the number of the row, which means that if it is first row 1 star, if it is second row 2 stars, if it is third row 3 stars, if it is fourth row 4 stars, that way I will keep on printing. If it is, then you see, just focus on the red color inner loop. So in the inner loop, initialization is same as the previous one, call equals to 1, increment is same, plus plus call. The statement or body of the for loop is same, that is print star space. Only difference is in the expression 2, that is the condition for loop. Previously it was call less than equals to columns or COLS capital, and there I mentioned that how many say columns I need to print. It was 5 columns. Now what I am doing, that since I know that in each row the row number of stars will be printed, so my variable is row here. And if it is row, then you see that simply it can print that required number of stars as per the given pattern. Okay. The next one, in this case the same thing, but you can consider that was the lower triangular, this is the upper triangular representation. Okay. So first I have to print 5 stars where I know that 5 rows will be printed, then 4 stars, then 3 stars, then 2 stars, then 1 star. Okay. Now again I request you to give a pause to this video and then try it by yourself. Okay. Now once you tried, then just for cross checking, or if you need any hint or suggestion, then you can come back and you can look at this solution. So for row equals to 0, so you please look at this one carefully. Purposefully I kept this one. So last time for was running from 1, that's why the loop was ending at small row, that is the variable row was less than equals to capital rows, which means constant integer. So started from 1, that's why up to less than equals to. But since here row starts from 0, then it will go up to less than. Now for the inner loop, which is colored as red, that is starting from 1 and is going to less than equals to. But you know, since I am not printing the number, so whether it will start from 0 go up to less than row, or it will start from 1 and will go up to less than equals to row, that is immaterial. So no need to think about that one, but you should not mix like row will be 0 and then it will go up to row less than equals to rows. If it is the case, then you will make one more in count, that is wrong, or that is a mistake. Now you see that first of all I know beforehand that how many rows are there. So absolutely no problem to print those many number of stars at the first line. So I will print that one. But the problem is that from the next onwards I have to reduce that number, and reduction means you can consider, and yes it is true, that instead of star actually I will print one space. Okay. So what I was printing previously, that star followed by a space. Next onwards, what I will do, that first inner loop will do this, first inner loop will do that instead of star space, instead of star there will be a space, and for the space there will be a space. That way I will print two spaces. Since there are two spaces, so that can be and that must be inside a double quote. But if it is a single space, then I can put that one in double quote or single quote. That's not a problem. Next, what I am doing, so after printing the space, then I am going to this column 1, column less than equals to rows minus row plus column, then printing star space. So what I am doing basically, if you remember the previous example, when I was computing that lower triangular, then row number of star was printed. In this case, row number of blank instead of star will be printed first, then remaining number, that is rows minus row, that number of star will be printed next, and that will make you the required figure. Okay. Now at this point you understand at least that when a problem statement will be given to you, so first you have to understand the logic, and then based upon that logic you have to come up with some algorithm or the steps to compute that one. That step either you can convert to a flowchart or you can keep in your mind, and then accordingly from that step you have to translate that one in C programming language or in C syntax. Now if you know one programming language, then we believe that you can learn other programming languages very quickly, because given the problem statement, understanding the logic and then thinking about the steps or the algorithm for that problem is important, and irrespective of the programming language, that is same. Now once you have the steps, then in order to convert that steps into a particular programming language, for that you need to learn the syntax. Now if you learn this syntax, then in future you can extend this concept to other languages like C++, Java or Python, etc. Okay. So here is one example for break and continue with the nested loop. So for nested loops, break and continue are matched with the nearest loop, for, while, do, while. So it is important. So I also mentioned when I when first I introduced break to you, that it will be acting on the closest loop to it. So here is one example. In this example you see that there is a nesting, and the nesting is, so while inside the while loop there is a for loop, and I believe that you understand it is allowed, although in the two previous examples it was for inside for or while inside while, but while inside for or for inside while, they are also allowed or permitted. Now if it is the case, in this case I am not just focusing on the say logic of this program. What I am doing, that I am having one while loop, and that while loop spans from here to here. Then I am having one for loop that spans from here to here, and there is one statement after the for loop, and inside the for loop there is one statement. Now if there is a break, and if I assume for a value of this k and I, this expression will be evaluated as true, then this break statement will be executed. If it will execute, then it will break from the loop for, but it will not break from the loop while. Okay, please remember that one. It is not the case that break can break any number of nested loop. It can break only that particular loop inside which it is declared. Now it is declared inside which? It is declared inside for. You may think that okay, it is declared inside while also. Okay, but it is also declared inside for, and which one is enclosing this one and which one is closest to this break, the action will take place on that one. So this break will come out from here to at this position, and then after this break, then this I equals to I plus 1 will start executing. Instead of If this condition is not evaluated, then it will go back to for loop and for loop will keep on going. But when this break will be executed, then it will come out of here and this I equals to I plus 1 will be incremented. Now if you want to break from both the loops, then you have to provide one break statement, but again two breaks inside this for loop will not work. So another break will be where? Somewhere outside this for loop, either here or here or here, okay, but not inside the for loop. If it is inside the for loop, then it will again act on the for loop but not on the while loop. Okay, so this is the pictorial view. If I say break, then it will break out of here. So follow this one, it breaks here and it goes here. Okay, so here is another example, and that example says that again I am not going into details of this logic of the program, but I wish to demonstrate only the break. As I mentioned that if I wish to break from the two nested loops, or then I have to have two break statement, one inside for, another inside while loop. Now there are integer variables, integer low, high, desired, I flag equals to 0. I am reading low, high and desired, I equals to low. Then while I less than high, then there is a for loop here, and if this condition is satisfied, if j modulus I equals to desired, then I am setting flag equals to 1 and I am breaking. If I break, then I break from where? It will break from here to here. Okay, now you see that this if is this loop. So this is the opening brace of if, this is the closing brace of if. If I execute break, it will break from the nested, the most nested or closest one, that is the for loop, and because of this break it will come out and it will control will go here. Now if this flag is evaluated as true and it is executed, then because of this break it will come out of here and it will go here. Okay, now for this particular situation, these two break will be executed simultaneously. Why? Because of this evaluation as true, flag is set as 1, then because of this execution of break it will come out of here, and after coming out of here it will test the flag, and since I already set the flag as 1, then flag equals to 1, and because of that one I am breaking, and I am breaking from here and I am going out here. Okay, now if I wish to break from both the loops in the nested format, then I will break this way. So one I will break from here, another I will break from here, and when I am breaking from here, then the information flag equals to 1, or the flag information I have to keep in my mind, and using that flag information I am breaking from here. Okay. Now another interesting thing, this comma operator mostly used in the for loop is that it separates expression. Its syntax is that expression 1 comma expression 2 comma up to expression n, where expression 1, 2 etc. are all expressions, different expressions, is itself an expression which evaluates to the value of the last expression in the sequence, and then it keep on assigning back. Since all but last expression values are discarded, not of much general use, but sometimes you can use it in the for loop as an expression 1. So in the expression 1, if there is a requirement of initializing two values, say when I am computing the factorial, then I need to initialize the fact or the product as 1, as well as the counter variable, that is also 1 or 2. If it is the requirement, then instead of declaring say product or fact outside the for loop, what you can do, that product equals to 1 comma then count equals to 1, or fact equals to 1 comma count equals to 1, then semicolon. If you do, then both the statements will be executed, and those two separated by comma will be considered as one expression. It is but useful in for loops by using side effects of the expressions. So here is one example. We can give several expressions separated by commas in place of expression 1 and expression 3 in a for loop to do multiple assignments. For example, for fact equals to 1 comma I equals to 1, I less than equals to 10, I plus plus I. So fact equals to fact multiplied with I. Now as of now what we are doing, that I am initializing fact outside this for, and then inside this one my initialization was as an expression 1 I equals to 1, expression 2 I less than equals to 10, expression 3 plus plus I. Instead now I am packing these two. Fact equals to 1 is one statement, I equals to 1 is my another statement, and they are separated by a comma, and this whole blue color will be considered as expression 1. They will be evaluated only once when I will enter to this for loop. Okay. Similarly, you can think of, okay, I am not describing it explicitly, that whether I can give comma operator here or comma operator here, and what will be the effect. Okay, so if there are more than one variables, then I can put say plus plus I comma plus plus j, etc. Then whenever this expression 3 will be evaluated, all will be implemented. Is it possible or not? You can try it by yourself and check. So here I am giving you one homework. So compute the following function given a value of x with the accuracy of 10 to the power minus 6. The function is fx equals to 1 minus x squared divided by factorial 2 plus x to the power 4 divided by factorial 4 minus x to the power 6 divided by factorial 6 plus dot dot dot. But what is the termination condition? So here the termination condition is that with the accuracy of 10 to the power minus 6. Please remember 10 to the power minus 6, so accuracy is very high. So you have to declare a variable with that kind of data type. What is the data type? You think and you implement that one. You should not use any math library functions or C function to calculate factorial, because as of now we didn't discuss C function, and a math library function like pow etc. for computing this one is also not required. You apply your logic, you see that there is a pattern, and that way it is incrementing. And it is also true that it is not required to say multiply 2x in order to get x square, then 4x to get x to the power 4, then 6x's to get x to the power 6. That is not required. You look at the pattern, and based upon that one you write a program. Next is, if I wish to compute the standard deviation, okay, then you know that what is the formula for mu and sigma, that is the average and the standard deviation. So this is the formula. So given list of numbers without any loss of generality, if I assume that the numbers are say integer numbers or floating point number, okay, then what will be the mean and standard deviation? So you think that whether I can able to do that one based upon what we have discussed as of now or not, and if yes, then how I can do that one. So grossly the steps will be like this: read in the number of or the size of the list, rather I should say, okay, or the number of numbers in the list, and then you have to read each number, then compute the mean and compute the standard deviation. Again, what I am suggesting, you think that based upon the loop structure what we have discussed, do while or for, and the say optionally you can use the break and continue statement, is it possible to compute the mean and standard deviation? Okay, so if not, then in the next class, okay, so you will get a definitely very good solution, okay, and you can consider this particular as the step for or the motivation for your next class. Okay, so that's it. So in these 3 consecutive video lectures upon iterations and loop, we started with a situation where I need to execute a group of statements multiple times repeatedly, and for that I need to iterate that one, and for that iteration I explained that 3 different loop construct In C, one is while, another is do while, another is for. There is a similarity between while and for, and we demonstrated also that these two loop constructs are same, whereas there is a difference between while and do while. While where there is a possibility that while will not be executed at all, means the block of statements inside the while loop or may not be executed at all, but that is not the case for do while loop. Also, during the condition setting for while loop, do while or for loop, it is also possible that if mistakenly you provide some expression which will be evaluated as true always, irrespective of what is the value, or you provide some non-zero value as the condition which is trivial and which is actually evaluated as true, then your loop will be in the infinite loop. If it is in infinite loop, then in order to come out of that loop, you have to give some break. But that is not the only use of the break. In other situations where if you made the result or required value you got and you do not wish to proceed with the loop further, then you can come out from the loop using the break statement. On the other hand, continue that if the situation demands that okay, I am at a position and from this position I am not interested to go further, or I do not wish to process rest of the statements in this block under this loop, then I will use the continue statement. Also, I demonstrated that if the loop is definite in nature, which means I know beforehand that what will be the number of iteration and what is the size of the iteration, then how I will write that one. Or if it is indefinite in nature, which means I do not know that how many times it will be iterated. There is a there is a terminating condition which will be decided in the runtime. So those things we have discussed. Okay. Now, if you have any query, any question, etc., keep on posting in our query form. Nevertheless, if you have further query, do not hesitate to raise that one during our doubt clearance sessions. Okay, that's it. Thank you.